one example of a very common and I think the most simple example of an unsupervised algorithm is k-means clustering. It's where k is the number of clusters. So let me show it to you. So as I said, in unsupervised learning, there's typically a cluster of data like these. So the human eye can see that there's 3 clusters, but the model doesn't know. It has to find out on its own. So just for the sake of illustration, let's say this is license price is FK. What do you have? Amul. These are 3 clusters, and then these are the following steps. I'll go through them. So what you do initially is initialize the centers randomly. So I'll be representing the centers using mu k. So let's say one center is over here, another center is over here, just randomly another center is over here. Mu1, mu2, and mu3. So that's the first step. Now the second step is you have to assign each customer to its nearest pizza center. So let's say, let's take this group. And for this center, let's take this. I should have done different color actually. And finally, let's say this is for Amul. Now, the next step is to update these centers. So as you can see, these centers are not exactly at the center of the distributions. So you have to try to bring it to the center of the clusters uh, so that you converge to the number of clusters, that is 3. So now what you do is you take the mean of this cluster and this cluster. Like you take mean of all the points, and in the next step you read somewhere over here. Same for the blue one. And same for the green one. And now we repeat the step again. You take the points nearest to the center. And you take the average again. So this moves towards this side. This green thing, green center. This becomes the cluster and this moves over here. This is the third cluster. And finally, this is the center of the cluster. And now the algorithm has, figured a way to find out partition the data into three clusters. Is there any doubts in this? So I'll just go through these steps again. First, what you do is initialize centers randomly. So one drawback is that over here you know that there are three clusters, so you assign three centers. And then the next step is you assign each point to the nearest center. Assigning. And third step is updating the center. And then fourth is just repeating these two till you converge to a cluster, a desired cluster, in such a way that you're partitioning all the data. So there was no human supervision over here. It was all done by the algorithm. So there's a question: how does a center choose which points are near it? And that's a good question actually. Uh, you can use different distance formulae. You can use Gaussian. I forgot what it's called. But yeah, basically it's UK minus, where K is like any center. Let's take K for constant for now. So mu1 minus x1 and mu2, mu1 minus x2, and so on. And then you take the minimum of them. So let me show it again. Let's say that these points. And like there's one center over here. There's another center over here. And the distance from the center to this point is smaller than this uh, center to this point. So you take the minimum of them, and this point can be classified to this center. You continue this for each and every point. Does that clear things up? So if my drawing wasn't that good, you could look at this picture. You have you can see that there are two clusters, but we don't assume that there are two clusters. We take the entire as one class, and then you randomly assign the centers. the red and the blue one, and we find the nearest points to the red one, the nearest points to the blue one, and classify them red and blue. And the D step is updating step, where you take the average of all the points, and this center moves towards the average. So this is updated over here. Same for the blue one. This is repeated again and again till we converge. So a disclaimer over here, like it doesn't need to always converge. That's one drawback of k-means clustering. It's sensitive to initialization. Uh, and and if there are any outliers, then even then it does not need to converge. Any doubts? We will repeat the steps to reassign centers till the same bunch of points for every center. Yes, that's correct part. So the last but not the least of the learning paradigms is another called semi-supervised learning. In this the algorithm we train is on a combination of labeled and unlabeled data. Typically, we take a small amount of labeled data and a large amount of unlabeled data. Uh, this actually helps in increasing the accuracy. Accuracy as in you are more correct more number of times. So the basic procedure in this is we cluster similar kind of data using an unsupervised algorithm. Maybe the one we used before, we can use it over here as well. K-means clustering. And then we used label data to fine tune our predictions to label some portion of the unlabeled data. This ensures that there's some kind of uh, supervision from us, but not that much at the same time. It's usually very small. It's somewhere between supervised and unsupervised learning. And this increases the accuracy significantly. Again, this is again bound to fail because of the same drawbacks we saw in unsupervised learning. It need not converge always, and then it need not be a continuous distribution as well. They can be outliers. I'll actually share an article which you can, it's fairly simple. You can go over it, get a basic feel for why it